projects. In this video, we are going to explain about project titled CNN based speaker recognition and language and test independent small scale system. The goal of this project is to develop a speaker recognition system that can identify the individual based on their voice, regardless of the language or specific words spoken. Unlike traditional speaker recognition system that rely on specific keywords, this study aims to create a more versatile system. The approach involves using the dense and convolution neural network in combination with Mel frequency spectral coefficients to build the speaker recognition model. The project emphasized the potential application of speaker recognition technology in various domains such as home assistance, telephone banking, and biometric identification. The primary goal of this project is to develop a speaker recognition system that can identify the individuals based on their voice without relying on specific keywords or language constraints. The system will utilize the dense and convolution neural networks in conjunction with MFCC to achieve the accurate and language independent recognition. Additionally, the project aims to investigate the potential applications of speaker recognition technology in diverse industries, including the personal or home assistance, telephone banking, and biometric identification. These are the basic requirements that are needed to build this project. Operating system as Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirement Python IDEL with version of 3.7. Methodology. These are the different modules that are developed to implement this project. The first one is upload speech dataset. In this module, the task is to upload the speech recordings of 5 different persons to the application. The dataset will serve as the input for further processing and training. And the second one is noise and MFCC processing. This module focuses on pre-processing the speech recording. First, the noise reduction techniques are applied to remove the unwanted noise from the audio. Then, Mel frequency spectral coefficient algorithm is employed to extract the relevant features. These features will be utilized for training both the CNN and random forest algorithms. And the third module is Run CNN algorithm. In this module, the extracted MSCC features are used to build a training model based on the CNN algorithm. The training model is trained using the extracted features, and the test data is applied to the trained model to predict or recognize the persons represented in the speech recordings. And the fourth module is Run Random Forest algorithm. This algorithm is obtained and utilized to train the random forest algorithm. The training data is used to build a random forest model, and the test data is applied to this model to calculate the prediction accuracy. And the fifth module is CNN accuracy and loss graph. This module involves plotting the accuracy and loss graph for CNN algorithm. The graph provides a visual representation of the performance of the model during the training process. And the final module is upload the test audio and recognize the speaker. In this module, the aim is to predict or recognize the person from the test data. The user can upload a test speech recording, and the CNN algorithm will process the input to determine the person represented in the speech. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of the different files. The first one is dataset file consisting of different persons and their voices. And here the model folder consisting of .h5 file, which contain the deep learning algorithm information. These .h5 files can be loaded into the project code during the runtime to utilize the trained model for various tasks, such as making predictions on new data or performing the specific operation. And the test speech is a folder consisting of the recordings of various persons that is used to test the model. and the main and test is the Python code files, and run is the bat file. Instead of executing the program in command line interface, we created the Windows bat file to execute the project. Now to run the project, double click on run.bat file. Here, this is the graphical user interface. With this, we are interacting with the program. First, double click on the Upload Speech Dataset button. And here, by this, we are going to import dataset from this folder. I am selecting the dataset folder and click on Select Folder button. And here, we get a screen of dataset is loaded. And then click on Noise and MFCC Processing button. Here, by this, it read all the audio files and then remove the noises and apply the MFCC to the extract features. In this screen, we get the application extracted from 7501 audio files belonging to the 5 different persons. And now data features are ready. And then click on Run CNN Algorithm button to train the CNN with this dataset. And the CNN speech recognition training model predicts the accuracy of 99.18. And to see the console for the layers assigned to that of CNN algorithm, and minimize this screen and click on Run Random Forest Algorithm button. Here, this random forest algorithm is generated with the pre-processed dataset, and it gives the accuracy of 97.06. And then click on CNN Accuracy and Loss Graph button. Here, it gives the graph in x-axis represents the epochs, and I took the 10 epoch, and in this graph, while increasing the epoch, we can see the accuracy get increased and loss get decreased to 0, which means model built with accurate prediction. In this graph, yellow line represents the accuracy and blue line represents the loss. And we can close this graph. And click on Upload Test Audio and Recognize Speaker button. By this, we move on to the test speech folder, and in this we get of different audio files and select any one of the file from this. I am selecting the A5 file and clicking on Open button. And here we get a screen. The uploaded speech recognized if a person named known Jens Stoltenberg and voice recognition as Madam. In this way, we can recognize the speaker and language and test independent small scale system by using the CNN. Finally, the project concludes that the test independent language independent speaker recognition system can be developed using the dense and convolution neural network along with MFCC. The system can achieve an accuracy of more than 75 to 80% using the CNN model. The study suggests that the speaker recognition has potential application in various industries, including the personal or home assistant, telephone banking, and biometric identification. The project also suggests that further studies can be conducted to improve the accuracy of the model and scale up the number of users. Thank you for watching.
For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.